Hi guys, welcome to our 40th webinar. In the last three sessions, we had discussed strategies of GMAT, the FAQs essentially, especially related to GMAT focus, the way the things have changed and now what is new in GMAT focus. So I think we're done with it for the time being. And in case you have any other queries, then please mail to us and we'll see if we can arrange another webinar on the same. Yeah. For now, we'll go back to content. So today we have a reading comprehension class. We will discuss a set which, in fact, a lot of learners find really difficult. And, it's a science-based set. And in fact, there are some people with science background who have also said that they found it difficult and they would like to discuss it. So that is why we just decided it's better to do it in the webinar, right? Because explaining a passage by writing, I'm going to be writing an entire essay in that case, right? Gets really cumbersome and it gets really cumbersome for you to read as well. So then let's discuss that set today. We'll first discuss the passage and, we'll try and find out the structure of the passage. So essentially my idea would be, let's say, someone who's not from a science background, how is he or she going to figure it out, right? How are they going to figure out what is written and what does it mean, etc. So we'll try and perhaps make some small diagrams to make sure that we understand, or you could also just visualize this. You don't have to make the diagram, but I would try and explain using some small diagrams so that it's clear. So the intent is to, to explain that someone who doesn't know about this topic at all, how will they handle a passage like this? Because we're certainly going to have passages which are out of a comfort zone, right? So we're going to discuss how to handle those. So once we're done with the structure of the passage, then we look at some questions. I'll give you about a couple of minutes for each question, and we'll discuss, the type of question and then, of course, the answer, etc. Yeah. So let's get started. I'll share my screen. All right. All right. So this is our passage. We'll start with discussing the passage, figuring out the structure, and then we'll look at the questions. Yeah. All right. Many stars are born in clusters of hundreds or thousands crowded within a diameter of a few light years. Now, someone who has a science background, for them, it's very easy to understand, but then there are still some basic things that that people should know. I mean, a little bit of literacy of every topic is required, as we've discussed in GMAT before. So many stars, and we should know that sun is also a star, right? And are born in clusters of hundreds of thousands crowded within a diameter of a few light years. So, what is light years? We should know that this is a measure of distance. Essentially, it is the distance traveled by light in 1 year. Yeah. This is not a measure of time. So these basic things you are required to know. This basic knowledge you must have, because without this, then it's going to become really, really difficult for you to navigate through this passage. Yeah. Okay, so then, the moment I read this, there is this one little figure that comes in my mind that, okay, so there is this is, an area of a few light years. Let's say the radius over here, it's, let's say, about 5 light years, whatever. So within this, they are saying that many stars are born in clusters of hundreds or thousands. So essentially, stars are born in a cluster. So lots of stars are born together in a small amount of space, yeah, very close to each other. That is what this sentence is telling me. Now, this is something, even with a science background, I may not know, but it doesn't matter. It's very easy for me to understand in case I have a science background. But if I don't, I can still figure it out if I know what is light years and, what am I talking about when I say stars, right? Okay, now these clusters usually disperse over a period of billions of years. So now they're saying that this cluster is going to disperse. So essentially, the star is going here, this is going here, this is, so everyone will separate out, right? The cluster will disperse over a period of billions of years. All right. Now, new evidence suggests that our sun also originated in a cluster. And we know that sun is also a star, right? And thus has many sibling stars that have scattered, leaving our sun relatively isolated. So now the point is that our sun, and all the planets go around it, etc., right? We know that. So they are saying that this also originated in a cluster like this. And so, of course, it had a lot of sibling stars. Sibling stars, from context, we know that these all are sibling stars. Let's say if this is the sun, then all these are its sibling stars. Yeah. So they're saying that new evidence suggests that our sun also originated in a cluster, and so it has many sibling stars, and they scattered because. So essentially, this is telling you that the sibling stars are not close to the sun anymore. Even if you do not know that the next star is like quite a distance away from it, doesn't matter. You have been given that leaving our sun relatively isolated. This means that the stars have all dispersed. Yeah. Okay. In 2003, scientists analyzed two meteorites. Now, you know what are meteorites, right? Small, let's say, pieces of rock, pebble, etc. So, tiny pieces from meteors, right? And do we know meteors? Okay, again, this is something that you might be required to know that meteorites do hit our atmosphere as well, etc. Right? So they do enter the Earth's atmosphere and then land on Earth. So in 2003, scientists analyzed two meteorites dating from the formation of the solar system. So these meteorites are also as old as the solar system. So from at that time, whatever billions of years ago that was, they detected nickel 60, the product of radioactive decay of iron 60. Okay, now again, you should know what is radioactive decay. Yeah? So when one element decays into another element, yeah, so some elements are unstable and then they'll keep decaying, and something related to half-life, etc. So just a little bit of idea is enough. Yeah. They're saying they detected nickel 60, the product of radioactive decay of iron 60. So essentially, iron 60 decays into, I'm told that iron 60 decays into nickel 60. Yeah. In chemical compounds where iron would normally be found. So they're saying that there are some compounds, whatever those, in this compound, for example, which has some kind of structure. I don't know now. I'm not going to use any chemical symbols. It's just going to confuse you more. But let's say that it has, normally iron is supposed to be in that particular compound, yeah, in that particular molecule, right, which is formed by lots of small atoms together. So iron is supposed to be here, but Fe, but it doesn't matter. But instead of this, we found that there is nickel, right? This indicates that the compounds originally formed from iron, which then metamorphosed into nickel. So even if I don't know, I mean, they're telling me everything. Look, the point is that we just have to be present and we have to read the passage very carefully, because they're going to give us all the information. Even if these are things that I don't really understand, they'll tell me. They're saying that it indicates that the compounds originally formed from iron. So they're saying that in these compounds, originally there was iron, but that finally decayed to give us nickel, right? And that is why we found nickel 60 in those meteorites. Okay. The iron had to form, reach the solar system, and be incorporated into the meteorites to form these compounds in the meteorites, right? Fairly quickly before it turned into nickel. So, what does it tell me? Even though I don't really know it myself, it tells me that it has a short life, a short half life, iron 60, that very quickly, talking in terms of the life of the solar system, etc., that very quickly your iron 60 will degrade into nickel 60. Yeah. So it is saying that we are given that the iron had to form, reach the solar system, and be incorporated into the meteorites fairly quickly before it turned into nickel. So all of this must have happened in a short span of time, right? Okay, therefore the iron must have originated nearby, probably from a supernova explosion within 5 light years of the sun, when the sun was about 1.8 million years old. So they are saying that, it is possible that, I mean, because iron could not have formed very far away. Yeah, because then by the time it would have reached our solar system, it would have already degraded into nickel, right? That's not okay. So, which means that iron would have formed somewhere close by. And they are saying that iron must have originated nearby, probably from a supernova explosion. So a supernova explosion must be the one in which all these, heavy elements are formed, like iron is formed within 5 light years of the sun. So if our sun is here, I mean, let's say if this is 5 light years, the supernova explosion must have happened over here. And you should have a little bit of idea of what a supernova explosion is. Essentially, it's a death of a star. Yeah, a big star. So, it'll, the star will become absolutely huge and it'll throw out all light, heat, dust, etc., whatever. So that is called a supernova explosion, right? So now they're saying that the iron would have formed in this supernova explosion. And it would not be very far from our sun. It must be within, let's say, 5 light years from our sun, because then iron would have formed and then it would have reached our solar system. It would have, entered into the meteor, formed that compound, and then the decay would have started, and it would have turned into nickel that we found, right? Okay. When the sun was about 1.8 years, a million years old. So it's telling us that at this time, perhaps it was like the early solar system. Yeah. If the sun had been as secluded as it is today, a supernova so close by would have been extremely unlikely. So they're saying that, if there were no stars around us, as secluded. So as we said that over here we had found out that our sun is relatively secluded, isolated, right? So they're saying that if sun was as secluded at that time also, when the sun was 1.8 million years old, we are given over here, right? This happened when sun was, so if at that time also the sun was relatively secluded and there were very few stars around it and a supernova happened so close by, the probability of that is very, very little. It's extremely unlikely that because supernova must not be an event then which takes place very regularly in the in the universe. Yeah, then it must be a rare event, perhaps. Okay. However, it would have been far more probable if the exploding star and the newborn sun were packed close together as part of a cluster. So, I know that 1.8 million years is newborn sun. So, we're saying that the sun was relatively very new at that time. So, they're saying that if it was a cluster, then it becomes far more probable. And that makes sense, right? If there are a lot of stars around it, then one star, let's say this one exploding into a supernova, it's a much better probability than if there are almost no stars around, barely one or two, and one of them explodes and becomes a supernova. That the probability of that happening is very, very small, right? So that is why they are saying then perhaps at that time then sun was in the cluster. They had not dispersed. People, these all these stars were close together. That increases the probability, improves it a whole lot. Yeah, as part of a cluster, right? Now, don't worry about it. I mean, we're talking about probabilities and all. Look, we're talking about events which happened, let's say, millions, billions, and billions of years ago, right? So then, it would be we would bank on higher probabilities. Of course, we don't really know exactly what happened, right? So normally this will be a game of probabilities. This hypothesis. So anyway, they're saying that this is a hypothesis. They're not saying that this is a fact, right? This hypothesis could explain the puzzling levels of heavy elements in the sun. Okay, so this tells me that there are heavy elements in the sun. And okay, so again, a little bit of knowledge would be really helpful. Knowing that hydrogen, helium, etc., are the light elements, right? And the heavier elements are your iron, etc., right? So that there are so this tells me that there are puzzling levels of heavy elements in the sun. Why? They'll tell me. Generally, the farther a star's birthplace is from the galactic center, the poorer the star is in heavy elements. Okay. Now, this tells me quite a few things. One, galactic center, think about it, that it's saying that, we're talking about the whole Milky Way galaxy, right? This is, let's say, if this is just our solar system, we're talking about the entire galaxy, yeah? The Milky Way galaxy. And of course, we're not in the center of Milky Way. We're somewhere on the edge. So not on the edge, as in, but not in the center. So it's saying that, where is it? Yeah, the farther a star's birthplace is from the galactic center, the poorer the star is in heavy elements. And sun has puzzling levels of heavy elements in the sun. Yeah. We have puzzling levels of heavy elements. I mean, we didn't expect the heavy elements to be there in the sun because we are so far away from the galactic center. Let's say, if the center is over here, then our sun is over here. This thing, we're very far away. But still, it is surprising that we have these heavy elements. However, a nearby supernova that seeded the meteorites with iron 60 could also have enriched the sun with these elements. So, it's saying that, this could explain why our sun has so many of the heavier elements, which we did not expect because it's really far from the center. The center is where you find the heavy. If sun had originated somewhere over here at the center, then we would have expected it to have a lot of those heavier elements. But the sun originated somewhere over here, and we don't expect it to have so many, but it does. So then, in case we say that okay, there was a supernova that occurred and pretty close to the sun, then I could also explain through that why the sun has these heavier elements, because the supernova, and I have been told that it creates these heavy elements like iron, and that because it spewed out iron everywhere, and then it reached the meteorites, and that is why the meteorites had iron. And that would also explain why our sun has iron, because some iron would reach our sun also. And that could have been responsible for why sun has heavy elements as well. Yeah. Could also finish this with these elements. All right. So, do we understand what is discussed in each? Okay, we'll come back to it later. Now, the odd skewed orbits of many comets also suggest that the sun once belonged to a cluster. Now it is saying that, so okay, let's make our solar system once again. Let's say this is our sun, and let's say this is our solar system. It's saying that the odd skewed orbits of many comets. Now we have comets in our solar system. So now their orbit is really skewed and it is odd. Like for example, perhaps it could be something like this, right? And comets, they revolve around the sun. So then why isn't sun more in the center? Why is the orbit more skewed, etc., right? Why is it odd? So it also suggests that the sun once belonged to a cluster. Look at that. Look at every point they are trying to suggest that sun belonged to a cluster, right? That is how we start. That is how, get, so it ends in, okay, so then this says that the sun was packed close together. Then over here also, this is supporting this one, this theory, this hypothesis, the supernova hypothesis. And then again, he says that the orbit of the comets, they also suggest that the sun belonged to a cluster, right? So everywhere he's trying to give, the author is trying to give us some point about, trying to give us data about, this hypothesis of his that sun originated in a cluster. Now, the internal dynamics of the solar system cannot account for these orbits. So they're saying that, of course, we know that the sun is here, then there are lots of planets, they revolve around. But he's saying that the internal dynamics of the solar system, they cannot account for these. There has to be a huge planet that will pull the comet towards it, and that is why the path of the comet would change, etc. He's saying that that is not happening. The planets cannot account for this change in the path, right? The skewed orbits. Okay, since the comets are beyond the gravitational influence of the major planets, so then whatever the big planets, the comets are outside the influence of the big planets. So they are not the ones which are changing the path of the comet. These comets were most likely stirred up by a star passing nearby, which would have been improbable unless the sun had many neighbors. So they think the planets are not the ones which are responsible for this kind of, the paths that the comet follows. So then perhaps there was a star. So for example, maybe a star passed by from here, right? And then that is why the comet moved closer, right? So they're saying that this could have led to the skewed orbit of the comet. Now, these comets were, yeah, and this would not have been possible if sun did not have many neighbors. If sun was as isolated as it is today, then stars would not have been, passing from close by. Now, as further evidence, astronomers are looking for stars similar to the sun in an arc along which the hypothetical cluster would have dispersed. So they're saying as further evidence for what? Further evidence for the hypothesis that sun was born in a cluster. Right? Astronomers are looking for stars similar to the sun in an arc along which the hypothetical cluster would have dispersed. So this hypothetical cluster that we were talking about right in the beginning, they're saying that this would have dispersed in an arc. So it's not like this went here and this went here and this went here. Likely they dispersed in an arc, that is, something like this. So were moving something like this in this direction. So some star went here, then our sun came here, and then this star perhaps went much farther away. It doesn't matter, right? What's that? Just a minute. Okay. So we get that the stars dispersed in a cluster along an arc. So they are trying to find further evidence that sun was born in a cluster. They're trying to find the sibling stars, the stars which are more like sun, along the arc where they're hypothesizing that this is the arc along which all the cluster dispersed. So they're trying to find on the way in case they can find stars which are like the sun. These stars should have a composition much like the sun's. So these stars, of course, since they were all born together, so then they would have similar compositions. And since they would have been enriched by the same supernova that enriched the early solar system. So, and all these stars, if they were this, we are saying that, okay, maybe there was a supernova and that enriched, while they were a cluster that enriched our sun. So then, uh, the stars which are around there in other stars in the cluster, they would have also been enriched similarly, right? If this was spewing out iron, then everyone around it would have got the iron, right? So they are trying to find other stars which are very similar to the sun along this particular arc, and if they are able to, and if they also, let's say, have those heavy metals, and they are also far away from the center of the galaxy, then it further supports the hypothesis that the sun was born in a cluster, right? So they're now looking for that particular evidence, right? So this is what is given in our passage. I hope you understand that, right? So quickly, here over a billion years and new event than a sun also. So here, what is he doing? He is introducing the topic. What is the topic? That our sun also originated in a cluster, right? This is what he's going to talk about. Then he's talking about the two meteorites, that the two meteorites were found with nickel, which then makes it likely that this, the iron was obtained from a supernova, which makes it likely that sun was born in a cluster, because lots of stars should be around for a supernova to occur. Otherwise, it's very, very rare that, the only one star that is close to you erupts in a supernova, right? It must be quite a rare event. So this supports that sun was originated in a cluster by talking about the two meteorites. Now here, this hypothesis could explain the puzzling levels of heavy elements in the sun. As here it is telling us why sun has those, that it could also explain another phenomena. What phenomena? That sun has puzzling levels of heavy elements. We don't expect the sun to have so many heavy elements, but it does. So the supernova theory close to the sun would explain it. And of course, the supernova theory supports the cluster theory, right? Here it tells us about the comets, that how, the very skewed and the odd orbit of the comets, it also suggests that there were stars close by. So again, this is giving support to the hypothesis that the sun originated in a cluster. And now, and finally, in the last paragraph, the author mentions that they are trying to, now astronomers are trying to find further evidence of this, right? So this is what the passage tells us. Any questions till now on what the passage says? I'll give you a minute. Should we go on to the questions? Okay, let's go on to the questions then. Are you able to view the question? If I move my window, does it get moved over there as well? Wait, let me put it down little just in case it's giving you trouble. Can you view the question? Any problems now? It can be inferred from the passage that if the hypothesis about the sun's origin is correct, then most of the sun's siblings probably, and just in case you cannot see a little bit of that, then it says that if the hypothesis about the sun's origins is correct, then most of the sun's siblings probably. So the Q&A is enabled. If you get the answer, let me know. Okay. Good, Zeno. Good. Divya, good. Akshay, good. Arshad, think once more. Okay, let's discuss it now. It can be inferred from the passage that if the hypothesis about the sun's origins is correct, then most of the sun's siblings probably. Okay, so where are we given information about the sun's siblings? Look at it over here. Astronomers are looking to find these stars should have a composition much like the sun. So we are given that their composition is expected to be much like the sun. since they would have been enriched by the same supernova that enriched the early solar system. So what we know about the sun's siblings is one, that they would have dispersed along the arc, right? The stars similar to the sun in an arc along which the hypothetical cluster would have dispersed, right? So one, we know that they would have dispersed in an arc somewhere, and that their composition would have been pretty similar to that of the sun, because the supernova would have given those heavy elements to them also, right? Even though they all originated quite far away from the center of the galaxy. Okay. Now, so options, what can we infer about the sun's siblings? So this is an infer question. Yeah, the passage will support what is given over here. This will not be mentioned completely the same way in the passage, but the data of the passage will support the option, the correct option. Okay, now have more heavy elements than is normal for stars born so far from the galactic center. Look, this makes sense, right? We can infer this. Why? Because we have been given that these stars should have a composition much like the sun, since they would have also been enriched by the same supernova that enriched the early solar system. And we know that because this supernova enriched the sun, so the sun has a lot more heavy elements than it should have, since it originated so far away from the center. So the same thing is going to be true for the sun's siblings also, right? It says that they should have a composition much like the sun. So this data given to us, it supports this particular option, our option A, right? All right. So then this makes sense. Let's look at other options also. But so, very, very rarely would we, perhaps in stated detail, if at all, but very rarely would we mark an RC option as correct without reading all the options. We must check every option, and we must eliminate the other four options that they are incorrect, and then we should arrive at the answer. Yeah, when something seems to make sense, that doesn't mean, okay, so my option A seems to make sense, let me just mark it and move on. That's not okay. Unless like you're really running short on time, is a different thing, but otherwise the chances of error increase a whole lot. In RC, you have to eliminate four options and then get to the correct answer. Yeah, you have to find that reason why an option is incorrect. Okay, so B are surrounded by comets and meteorites with odd skewed orbits. Look, now nowhere in the passage is there any data which says that all or not all, okay, maybe most siblings of sun should have comets and meteorites around them, right? Who says that every star should have comets and meteorites around them? We don't know that, right? We are not given in the passage. Even if most stars have, we don't know it, because the passage doesn't give, and the passage is meant for everybody, whether they have a science background or not, it doesn't matter. So that means that this particular option is not supported. We cannot infer it, right? Will be identified as the stars along an arc through the galactic center. Now, it says that through the galactic center. Now, we are not given that the arc passes through the galactic center, right? We know that there is a particular arc, right? But we know that it is quite far away from the galactic center in fact, right? We know that the sun and its siblings, they originated very far away and they dispersed there only. I mean, of course, they are not found through the galactic center. That has not been given to me anywhere, right? Again, that data is not available. So this particular thing means that this is incorrect. Yeah. They remain crowded within a cluster with a diameter of a few light years. Now, the, we know that the siblings dispersed, right? So the siblings probably remain crowded. That is incorrect. Right? We are given that they dispersed, so wrong. Now, they contain chemical compounds that include nickel 60 as well as iron 60. Look, we are given that they would likely have heavy elements, right? Now, do they have chemical compounds? Did they form chemical compounds? We don't know even whether the sun has chemical compounds, right? We know that it has those heavy elements. But then the chemical compounds, if you remember, were found in the meteorites. The meteorites had those chemical compounds, right? So not our sun. And anyway, we don't know whether it will have both nickel 60 as well as iron 60. I mean, if most of the, if all the, let's say, iron 60 has become nickel 60 in the sun also, it's possible that the same thing happened with the siblings also. So in any case, we know that this is also not correct. Lots of red flags over here also. Yeah. So of course, as we thought, the answer over here is A. Does that make sense? Are we good with it? If you have any doubts about this, let me know. No? Should we move on there? Okay, great. So yeah, that's true. Look, once you understand the passage really well, then the questions become quite simple. Yeah. Okay. I'll not put it right at the top. I'll move the passage in a bit. You read the question properly first. I'm not sure if. Yeah, it's visible now, right? The second paragraph mentions the nickel 60 in two meteorites in order to support the conclusion that. Yeah, Arden good, Reno good. Mm-hmm. Yeah. So your name is not appearing over here, but yeah, you're right. Akshay, no. James, think again. Okay, let's take a look at it together now. The second paragraph mentions the nickel 60 in two meteorites in order to support the conclusion that. So, we're looking for the function. This is a function question, right? Mentions the nickel 60. Why does it mention the nickel 60? What is it? What is the purpose, right? What is it trying to support? To support the conclusion that, okay, the meteorites date from the formation of the solar system. No. So look, this is the information that it gives us. It says that the analyzed two meteorites dating from the formation of the solar system, then they detected nickel 60, etc. Right? And then he goes on to tell us that, okay, yeah, nickel 60 means that there was iron 60 over there because these compounds have iron. Then he says iron is a very heavy element, and this means that perhaps there was a supernova because of which, the supernova would have given the iron. Then, if there was a supernova, then that means that the sun was born in a cluster, right? So, this is the entire logic of the second paragraph, as we had discussed before, right? Because the probability that there would be a supernova would be, high only if there are lots of stars around the sun, right? All right. So now, yeah, so we said this one is not correct. Then nickel 60 undergoes radioactive decay even after it has been incorporated into chemical compounds. Look, this is true, right? Please understand, we are given that this is correct. This is true, but is this the answer? That is the question. Yeah, they detected nickel 60, the product of in chemical compounds where iron would normally be found. This means that iron formed the compound, and then the decay happened within that compound, and that compound was found, right? So nickel 60 undergoes radioactive decay even after it has been incorporated into chemical compound. Okay, nickel 60 undergoes radioactive decay. Anyway, this is irrelevant. Iron 60, I mean, if it were iron 60 undergoes radioactive decay, then we would know that, yeah, this is correct. But it is not the answer, of course, because this is not the reason why nickel 60 is mentioned in meteorites is mentioned, right? The intent of the author is not to tell us that, hey, you know what, iron 60 decays and whatever. No, that is not the point. The intent of the author is to tell us that, to give support. What is it in order to support the conclusion? What is it he trying to support? The author is trying to support that sun was born in a cluster, right? So then, of course, incorrect. Even if this were iron 60, it would be true, but it would not be the correct answer. I hope you understand the distinction between them. This is what, we call traps. Sometimes people fall for this, that, you know what, this is given, this is true. Then is this the reason? Is this what, was nickel 60 mentioned to support this particular conclusion? No. It is something, that we are inferring based on the data given to us, right? But it is not the conclusion that is being supported. Now, the solar system contains more heavy elements than would be expected given its probable birthplace. Now, again, this is perhaps correct as well, right? Because we know that the sun does contain more heavy elements than would be expected given its probable birthplace. But then, is this the reason? Again, just as we said that if this were iron 60, then this seems to be correct. This seems to be true. But is this our answer? Again, no, because we have to find the reason why nickel 60 was mentioned. What is it supporting? It is supporting which conclusion? So we have to find the conclusion over here, right? Which was that sun was born as part of a cluster. Right? So again, no. Then D, our solar system was seeded with heavy elements by a comet about 1.8 million years ago. Again, this is incorrect. It was seeded by a supernova is what we are hypothesizing. So the newborn sun was part of a cluster in which the supernova occurred. This is correct, right? So the author does mention nickel 60 found in the meteorites to tell us at the end of it all the conclusion. Look, there's a conclusion over here that the sun was packed close together as part of a cluster. Then there is an intermediate conclusion, right? Understand that, and that they have not given in the options with good reason, because that I would also call a conclusion. And what is that intermediate conclusion? That this perhaps the nickel 60 was found means that perhaps there was a supernova explosion close by, right? Because otherwise, how would the heavy elements come, right? So this would be kind of an intermediate conclusion that there was a supernova explosion close by. And then from that, we are deriving our conclusion that, but you know what, supernovas are so rare. So there must have been a lot of stars around the sun. And that is how we are strengthening this particular conclusion that sun was born in a cluster, right? So this is our answer. I mean, in case there was something, given which says that because that a supernova explosion took place close to the sun, then we would be a little lost, because that would also be an intermediate conclusion. In fact, that would be the conclusion that it is supporting directly, and then that conclusion is supporting our main conclusion. Right? All right. Let's go on to the next question. Any doubts over here? Any issues over here? Okay, let's go on to the next question. No, Rani. Think once more. James, good. Arshad, good. Divya, good. Yeah, SG, good. Yeah, Arun, so they are supposed to be challenging, but since we have analyzed the argument, the passage really well, since we understand the passage, that is why then they would seem a little easier to handle. Yeah, certainly. Yeah. Okay, let's take a look at the question now. To support the claim that a supernova once exploded near the sun, the passage mentions that. Okay, so supernova, everything it was mentioned in our passage too, right? We should know the structure of the passage, isn't it? So we said that over here it mentioned all that iron nickel thing, and then the supernova thing, and finally this now the cluster thing, right? So this is a claim. Do we support the claim that a supernova once exploded near the sun? This is a claim. It is a hypothesis. It's not given as a fact, right? This is what the author's opinion is. This is what he wants to tell us. Just like in a CR question, we talk about it, right? This is just a claim. Yeah. The passage mentions that. Now, what does the passage mention to support this? So essentially, we should have a fact given to us in the passage which is supporting that a supernova once exploded near the sun. Supporting, not proving it. Don't worry about that, right? But supporting. Okay. Now, our sun was born in a particularly large cluster of stars packed close together. This is not given anywhere. The passage does not mention this anywhere, right? It's a stated detailed question. We should have the data given to us, the fact given to us. It is saying that the passage mentions that. So the fact which is supporting our this particular claim, a supernova once exploded in the sun, should be given to us over here. And the passage doesn't mention anything about large cluster or small cluster, right? So not the answer. Okay, the levels of heavy elements in the sun are unusually high given how far it was from the galactic center when it was born. Look at this now. Here we know that this part has been discussed here in the third paragraph, right? This hypothesis could explain the puzzling levels of heavy elements in the sun. We're saying that this hypothesis of there being a supernova and etc., this could explain the puzzling levels of heavy elements in the sun. So we are given that there are heavy elements in the sun. It is a fact, and it is supporting generally the farther a star's birthplace is from the galactic center, the poorer the star is in heavy elements. However, a nearby supernova that seeded the meteorites with iron could also have enriched the sun with these elements. So, based on the facts, based on what we see, we can, this particular data, it is supporting our hypothesis, it is supporting our claim that a supernova happened close by, right? This is data, the fact that the sun has heavy elements which are unexpected based on how far it is from the galactic center. This is supporting that a supernova happened close by, right? So this certainly makes sense. So let's just hold on to it. As we said, we're still going to look at all the options. Many comets have odd skewed orbits. This is given to us over here. We know that this is, it says that many, but then what does it support? It supports that there were stars which were, whizzing by the sun close by, and that is why the comets, the orbit changed and became skewed, etc., right? So then this does not talk about the supernova. It has no connection to that. So this is also gone. The internal dynamics of the solar system cannot account for the odd skewed orbits of many comets. As we said, the orbit of the comets are irrelevant where supernova is concerned, right? Stars with compositions similar to the sun form an arc along which a hypothetical star cluster would have probably dispersed. Now, does this, stars, they form an arc along which a hypothetical cluster would have dispersed? Does it support the supernova theory? It doesn't, right? There is an arc, and they would have dispersed along that. Doesn't support that there was a supernova. This doesn't provide us any data, right? So again, this is also not the answer. So then, of course, our answer over here has to be B. This is a fact that supports the supernova hypothesis, right? So whenever we make a claim or a hypothesis, how do we provide support to it? We find out facts around it, right? That, oh, it is consistent with this. You know what? Oh, we observe this in nature, and this, strengthens our hypothesis that, okay, maybe this happened, right? So that is what is given over here. Does it make sense? There's some elements of critical reasoning in this. That's correct. There are some elements of critical reasoning as well, where we say that there is a claim, and what is it that supports that particular claim? Think about it. In a critical reasoning argument, you do the same thing, right? Your claim is the conclusion of the argument, and when you say that, what supports it, you're looking for premises, you're looking for facts, you're looking for data. As simple as that, right? It's exactly the same concept over here as well. Make sense? Yeah, yeah. Everything is going to be interconnected, of course. And sometimes, once in a while, an RC question, an RC set would have a question which looks exactly like a critical reasoning question. Yeah. Very possible, right? Okay, let's move on to our last question on this passage. Main purpose. So, universal question. Now, we generally would expect to see one universal question at least. I hope you can see the question. So here you shouldn't really need to go back to the passage. Just read the options and select the answer. You know, anywhere universal questions, that too appearing almost at the end. So you're very comfortable with the passage. So then you shouldn't need to go back to the passage. Mhm. Yeah, yeah, good. Quite a few of you have already got the correct answer. Good. I'll give you another minute. Good guys, almost all of you have got the correct answer and almost everyone has responded. That's great. The main purpose of the passage is to, we've discussed this now while we were going through the passage and then in the questions also, that time and again the author is coming back to that one hypothesis, that one main point. What is this? That sun was born in a cluster of stars, right? So let's just look at the options. Describe how a supernova explosion near the newborn sun altered the composition of the solar system. No, that's not the main purpose for sure. Present evidence that our sun was born in a cluster of stars that has since dispersed. Correct, right? So this is exactly what we were looking for. As I said, everything comes down to that. Here it introduced this. Here it finally, this is what it came down to after all this explanation. Here again, it is supporting that a supernova happened, and in effect then supporting that the sun was born as a cluster. Then again also it says that also suggests that sun belonged to a cluster, and then so it's giving another point. And then as further evidence, it's saying that astronomers are trying to find further evidence for the same hypothesis, what the sun was born in a cluster. That has since dispersed, correct. But in any case, we'll still, read the options. Explain the unusually high level of heavy elements in meteorites and in the sun. It does explain, it does give us a hypothesis, it does give us a theory, but is that the main purpose of the passage? It is not, right? As we said, it's an, in one of the paragraphs, it's an intermediate conclusion, which again leads to the main conclusion, leads to the main point, which is the sun was born in a cluster. So again, this is not correct. Assess the claim that stars with compositions much like the sun's are distributed in an arc through the galaxy. Um, we are not trying to assess this particular claim, right? So that is not the purpose. We are saying that it is likely, and we are trying to find whether there are such stars distributed, because they are going to support our hypothesis, our claim, which is still that sun was born in a cluster, right? So we're not trying to assess this particular claim. No. Then discuss the hypothesis that a star cluster accounts for the odd skewed orbits of many comets. Again, look, these are all small parts of our passage, right? The main intent of the passage, the theme of the passage, something that the author is focusing on, and the author is providing us various little pieces of data to support one thing, right? And that one thing is the main purpose of the passage. It's very similar to the conclusion of an argument in CR questions, just that it is on a smaller scale. You have just 3-4 lines and then you have the conclusion. But there is always a reason. Look, think about it. There is a person behind this passage, right? Someone who's, as I've told you, that even in CR and in RC as well, try to visualize that someone is saying it to you. Don't try to, don't just read it as words on paper. Try to visualize that this is what someone is saying. Then it'll make sense. When we say conclusion is a claim, a hypothesis, the author's opinion, etc., that just means that it is what the person is trying to tell us. That is the main point in his mind. He wants to, you know, it is not a fact, right? But this is a point that he wants to get across, and to say that, right? For example, let's say ABC party is the best for this country. Let's say someone wants to say that, and then there this is the person's opinion, but then this is our conclusion, this is our claim, this is our hypothesis, whatever. But then he needs to give data to support it, and those are our premises, and this is true everywhere. This is true even when we talk about an RC. There is the reason why, there is this one particular reason why the author, opened up his laptop and started typing that, okay, I want to, make a statement. This is what I want to tell people, that my reader, I want to get this message across to the reader that this is the best party for our country, for example, right? So then, similarly, for every passage, there is this one thing that the author has in mind, that this is what I'm going to tell the reader. So, for example, if it is a heading, right, if he writes a very simple, plain heading where, he gives you the content of what he's going to write about, then what will that be? Again, that will be the main purpose of the passage. So, for example, in case this passage had to be given a heading, what will the author say? What will he write? The author will write that sun was born in a cluster, which has since dispersed, for example, right? So, in that sense, it's extremely similar to a CR question. Yeah. All right. So, we're done with the discussion of our today's set. Any questions anyone has, then let me know. Next week, we will most likely continue the discussion of the content. Perhaps we are going to do verbal once again next week. I'm not really sure. But then, there are still quite a few questions that learners have asked and they're not very comfortable with. And of course, it's far easier to explain on a webinar. So perhaps we'll continue with verbal, but then let's see, I'm not 100% sure. Strategy, yes, you are free to send whatever strategy questions you might have. You should check out the last 3 webinars. In that, we have discussed everything. I mean, whatever I could think of and whatever learners asked. So, how to attempt the focus and what are things that you have to keep in mind on test day, and then how to, what should be your pacing plan, for example, how to ensure that you don't fall short on time, how to prepare for quant separately. We've discussed the list of careless mistakes, and then we've discussed how to prepare for verbal, for DI, how to manage time in each. So all those things we have put together in the last 3 webinars. So check those out. In case there are still questions which have not been answered over there, then of course, please write in, and then, we keep a strategy webinar as well. Of course, I'm open to it, but there need to be enough relevant questions to discuss, right? Otherwise, in case there aren't enough, then I'll just respond on the mail. Or maybe I'll put in a small YouTube video. We'll see about it. Yeah. Okay. Yeah, okay, great. So if you've started the practice test, that's wonderful. And I'm glad to know that, you're doing well in the easy and the medium ones. Look, as I've said before, that those practice tests are very, very similar to how your official questions are going to be. I know that your exam is approaching soon. Doesn't matter. The language is also pretty similar to the actual GMAT question language. Of course, the questions are like slightly trickier than what you might see in GMAT, as in the easy question will be slightly maybe trickier than the easy question of GMAT, the medium will be slightly trickier. So, we've gone, let's say, a step ahead in the concept, in the logic, so that if you, see that, you're able to make sense of it. So whatever you would see in probably an actual GMAT question, we've gone, one step ahead in the concept application. So great. In case, easy and medium are going very well, good. Hard, yes, I can imagine that they are hard. So in case you're able to do 4 or 5 questions also hard, that's good. That itself is good enough. So don't worry. Hard is pretty much, let's say, I would say, some of the hardest that you could see on GMAT. So then you know. Of course, they're all based on the same concept, and they are not heavy on the calculation, nothing like that. Just that they are a little tricky. So they are some of the hardest that you'll see on GMAT. So then, even if you do like 50% of them correctly, that's great. Yeah. Sure, Divya. Yeah. So, let us know and write into the admin. Let me know what your progress is like. And in case there are any queries, just write in. And they'll get back to you in case there is, any specific direction that you will need. Then I'll get in touch with you as well. Don't worry. Yeah. All right, guys. So that's it for today. I'll see you guys next Wednesday. And I'll let you know what we're going to discuss. Yeah. Okay. Bye. Take care.